You know that feeling, right? That moment of just pure magic.
Oh, absolutely. It's intoxicating.
You ask a large language model to write some, I don't know, complex block of code, and it just works perfectly.
Yeah.
First try.
You feel like you've skipped 4 years of a CS degree and gone straight to the finish line.
Right. But then you try to make one small change. You need to tweak a variable or maybe just fit it into your file structure, and boom.
Everything breaks.
Everything breaks. You spend the next 2 days chasing errors, breaking more things, until you're just staring at this tangled mess you don't understand. And you quit.
That mess, that is the classic result of what we call vibe coding. You're just vibing with the AI, no structure, no plan, and it's the #1 reason these early AI projects fail.
So today we're taking a deep dive into how to escape that exact cycle. Our mission is to pull out the concrete systems, the mindset, used by places like Google and NVIDIA.
Right. We want to move you from just, guessing with prompts to reliably building real applications that last.
We're going to transform you from a vibe coder into an AI engineer.
Yeah, we'll cover the history, this idea of Software 3.0, the huge difference between the vibe coder and the architect, and the tools you actually need. And most importantly, this idea of the human in the loop. So let's unpack this.
To really get why we're even talking about code this way, I think we need a little historical context. The way we build software has gone through, 3 big stages?
3 fundamental shifts, yeah. So Software 1.0, that's the starting point. Think way back, like the 1940s onwards.
The old school.
Completely, it was all manual coding. Every single line was written by a human. If you use a cooking analogy, you were writing the recipe by hand.
And if you forgot to write add salt, the dish had no salt. Simple as that.
Exactly. The computer only did what you explicitly typed.
Then, around 2012, things started to change. We entered Software 2.0 with machine learning. That's when we started hearing about neural networks.
And a neural network is really just an algorithm that learns rules from huge amounts of data. It finds the patterns on its own.
So we stopped writing the rules ourselves. We'd just feed the computer, say, 1,000 pictures of a cat, and the system would figure out what cat means.
Right. In that cooking analogy, it's like showing a chef 1,000 photos of a perfect pizza. They'd have to figure out the recipe through trial and error.
And that brings us to now, Software 3.0. This really kicked off around 2019-2020 with large language models.
This is where the game totally changed, because now we can program just using plain English.
You don't need to know the technical syntax of the kitchen anymore. You just sit down, tell the waiter, the LLM, you want a spicy, thin-crust pizza, and they handle the rest.
And that simplicity is it's blowing up the market. I mean, the scale is hard to even imagine.
You mean beyond just regular software?
Way beyond. The current B2B software market is, about $230 billion? But the entire labor market paying people to do jobs, that's in the trillions.
And now AI agents can do those jobs, answering emails, analyzing data.
Exactly. So the market for what software can do is about to grow, maybe 50x, even 100x. The barrier to entry is just gone. You don't need that formal degree anymore. You just need to communicate effectively.
So if the market is going to expand that much, where should a beginner focus their energy first?
Focus on learning to communicate effectively with the models, not on mastering old school programming syntax.
That feels like the perfect transition into this core idea. Vibe coding versus AI engineering.
It's the whole philosophy. And vibe coding at its heart is it's lazy. You're leaning 100% on the AI to get it right.
You're not looking at the code, not planning the file structure.
You probably don't even know which file does what. And the biggest consequence of that is something called technical debt.
Right, the house analogy. If you're building a house just on instinct, technical debt is like building walls without checking if they're straight.
It looks okay for a minute.
For a little bit, yeah. But then you try to put the roof on or add a second floor, and the whole thing just collapses. That's why these vibe-coded projects, they almost always die within about 60 days. They just get too messy to fix.
And look, I gotta be honest here. A bit of a vulnerable admission, but I still wrestle with prompt drift myself sometimes.
You do?
Oh, yeah. It's so tempting, when you're tired or you're in a rush, to just let the AI handle it all. But that's the trap. That is the 60-day trap you have to fight every single day.
So the way out is AI engineering. It's a total mindset shift.
Completely. You are not the builder anymore. The AI is the builder.
You're the architect. You hold the map, you check the work, you understand the foundational pieces. That control is how you build things that last for years and actually make money.
So beyond that architectural planning, what's the single most important tool to help a beginner stay in that architect role?
You need a tool that gives the AI full context over your whole project instantly.
Which brings us to the toolkit.
Exactly. The tools that enforce that structure. For level 1, where everyone should start, the tool a lot of engineers are recommending right now is Cursor.
It looks just like VS Code, which most people know, but it has the AI baked right in. It's all about creating project-wide context.
Meaning it knows about all your files all the time.
Yes, and there are 3 features in there you just have to master. The first is called Cursor tab. We call it the mind reader.
The mind reader, I like that.
As you start typing maybe a variable or a function, you'll see this faint gray text appear, suggesting the rest of the code. You just hit tab and it fills it in. It feels like it's reading your mind.
Okay, that handles the boilerplate. What's next?
The second is Command K. This is your editor. This is for changing existing code. You highlight a small chunk of code, just a few lines.
You're being very specific.
Extremely. You highlight it, hit Command K and say, add error handling here, or make this cleaner. It only changes that one specific part, which limits the blast radius of any mistake.
And the third feature, the most powerful one, is Command I, the composer.
This is the big one. It opens a sidebar where you can talk to the AI about the entire project. It's read everything.
So you can actually say something like, create a new file for user login.
And it will create the file, write the code, and this is the crucial part. Link it to your existing navigation files automatically. It manages multiple files at once.
Whoa, wait a second. So you're saying you could scale that like across a massive data pipeline or use it to manage, I don't know, a billion queries without having to link anything by hand.
That's the power. It's truly transformative. It makes the architects so much more productive.
Okay, quick practical tip. For the model choice, you mentioned starting with Claude 3.5 Sonnet. Why that one specifically?
For beginners doing coding tasks, my advice is to start with Sonnet. The general feeling in the engineering community right now is that it follows complex, multi-step instructions really, really well. It just reduces friction.
And once you're good with Cursor, you move to level 2, which is coding agents.
Yeah, we use the intern analogy for this. Cursor is a tool you hold. An agent is like an intern you hire.
You give it a task and walk away.
Exactly. You say, build me a login page, and you come back in 20 minutes. It runs, it finds its own errors, it fixes them, and it tries to complete the entire job by itself.
What are some good examples to start with?
Replit Agent is a good one. It's in the browser, very friendly for beginners. Windsurf is another. Terminal agents are a bit more advanced, so I'd say stick to the browser-based ones first.
So with all these tools that handle the actual typing, what concepts are absolutely necessary for the architect to understand before they even start?
Forget the syntax. You need to focus intensely on understanding the core software concepts first.
And that really is the secret sauce, isn't it?
It's everything. You don't need to memorize where the semicolon goes anymore. The AI does that. But you have to learn the high-level concepts so you can guide the AI's decisions logically.
Okay, so let's list them. The 5 essential concepts to master. You should ask your AI to explain these to you.
Number 1, front end versus back end.
2, what a database is. It's basically a digital filing cabinet.
3, the ATI. The waiter analogy is perfect for this. It's the go-between for 2 different systems.
4, environment variables. These are your secret keys and passwords, and this one's critical.
Oh, it's so critical. If you don't understand this concept, you risk the AI accidentally pushing your secret keys, your digital wallet, to a public place like GitHub.
Which happens more than you'd think.
It really does. And the 5th concept is deployment, which is just the process of putting your app live on the internet.
So how do you learn these?
You use the AI to teach you. Open Cursor's chat, that's Command L, and type in a very specific prompt. Something like, I'm a beginner. Explain what an API is using a simple real-world analogy. Do not use technical jargon.
You have to be the manager, not the intern. Control the decisions. A bad prompt is asking, what should I build? It's too passive.
Right. A good prompt is specific. I want to build a to-do list app. Give me 3 tech stack options and explain the pros and cons of each for a beginner. Then you read them and you choose the path.
Let's talk about the common mistakes, the tuition fee you pay when you're learning this.
Yes. Mistake number 1. Accepting code blindly. You never just click apply. You have to read the comments, check which files it's going to affect, and then commit.
Number 2 is changing too much at once.
Oh, this is a huge one. Don't try to build the whole app in one prompt. Go in subtle steps. Build the login form. Check it. Now, build the database connection. Check it. It's like stacking Lego blocks, one at a time.
And the third mistake is giving up when it gets hard.
The first hour is always magic. But then you hit that first real bug, and it takes 30 minutes of just grinding to fix it.
That 30 minutes, that's the tuition fee. You learn more in that struggle than you do from any piece of perfectly generated code. You just have to push through it.
So how can an engineer ensure their code doesn't secretly revert to that vibe code messiness over time?
Schedule regular AI reviews to find unused code and refactor for cleanliness.
Okay, let's put this all together. Let's walk through building a simple daily expense tracker step by step the way an architect would.
Perfect. So step one is the setup. You create a PRD, a product requirements document.
Which is really just a simple text file, plan.md. And the prompt you give the AI is key. You say, goal, an app to add expenses and see a chart, tech stack, Python and Streamlit, .data. A simple CSV file, write a step-by-step plan, and you add this sentence, do not write any code yet.
You have to insist on the plan first.
Always. Step 2 is architecture. You review that plan, and then you ask the AI to create a detailed readme.md file that lists the folder structure and explains what every single file is for.
So you know the map before you start. You're not working blind.
Exactly. Then steps 3 and 4 are phased coding. You start with the skeleton. Use Command-I to create the first few files like requirements.txt and a basic hello world app.py.
You run it, make sure it works, get that small win.
Right. Then you phase in the logic, you add the input form for the expense, the amount, the category, and tell it to save that data to a CSV file.
And then comes step 5, which is inevitable, the review and fix.
You're going to hit an error, maybe a file not founder. This is the learning moment.
Sure.
You don't panic.
You use the debug with AI button or paste the error in and ask why it happened.
And that's where you learn a core concept, like realizing you forgot to create the CSV file in the first place.
Finally, step 6 is the polish. Once the core works, you prompt the AI to add a nice pie chart that shows your spending by category. It's iterative, it's controlled.
So if someone follows this structure and builds this little app, what's the fastest way for them to build real-world confidence?
Don't just build it locally. You have to deploy the application live onto the internet.
That's key.
That really is the core concept we wanted to get across today. The difference between people who make money with AI and those who are just playing with it is, it's all about structure.
Be persistent, be logical, own your code.
You don't need to be a math genius anymore. You just need to be the architect.
And there is a wide open seat at the table for you. The software world is going to grow massively next year.
So here's a personal challenge, a learning roadmap for the next 4 weeks.
Let's hear it. Week 1. Just install Cursor. Get comfortable with Command-K. Build a Hello World app. That's it.
Simple start.
Week 2. Build a calculator or a to-do list. And focus specifically on using Command-I to work across multiple files. Get a feel for that project context.
Okay, what about week 3?
Week 3 is all about deployment. Ask the AI how to put your little Streamlit app live on the internet. Learn that process from end to end.
And the final week?
Week 4. Tackle the hard stuff. Ask the AI to teach you about APIs, and then build a simple app that uses live data, maybe from a weather service.
So don't be a vibe coder who relies on magic. Be an AI engineer who relies on structure.
Exactly.
What simple, structured project will you build this weekend?